In this video, we are going to quickly go over how binary numbers work. So if you see a bunch of ones and zeros and feel like you're in the Matrix, this video is for you because the explanation is actually pretty simple. Now, to start, forget binary completely for a minute. We are just going to talk about the good old decimal or base 10 number system in a way that maybe you haven't thought about since you were a kid and you were first learning to count and do math. So let's pick a random or arbitrary number, say 317. And you can look at that number and immediately know what it means. But you might remember from when you were a kid learning that numbers like this have what you would call in words the ones, tens, and hundreds place. So when you're a kid and you have the little blocks and units of 1, 10, or 100 and you're learning to count, each one of these numbers represents how many of those blocks you would need. So to build this number out of the little blocks, I would need 7 of the little individual ones blocks. I would need 1 of the big tens blocks. I'm not going to count if I actually did that right, and then I'm not going to draw out the whole thing, but then there were like the big squares, made up of 100 blocks. So to build this number, I would need 7 of these, 1 of these, and 3 of these. I kind of drew them in reverse order there, but you get the idea. This would add up to 317. So another way I can write that out mathematically is I say, okay, this is the ones place, so I need 7 ones. I'm going to multiply 7 by 1. This is the tens place, so I need 1 10. I'm going to multiply 1 by 10. And this is the hundreds place, so I'm going to need 3 100s. And if I add those up, 3 times 100 plus 1 times 10 plus 7 times 1, that gives me 317, which in this case seems kind of circular because that's what we had in the first place, and you already knew that just from looking at this number. However, this approach is what's going to be useful when learning how binary works. So I'm going to redraw this, and we can also think of each of these digits as represented by a power of 10. So the ones digit is 10 to the 0, the tens digit is 10 to the 1, the hundreds digit is 10 squared, and how exponents work is maybe really a topic for another video, but a quick aside here. So 10 to the 0 is actually equal to 1. Why that is 1 instead of 0 is, again, topic for another video, but think of the exponent as the number of times a number is multiplied by itself. So 10 to the 1 is just 10. 10 squared is 10 times 10, which equals 100. 10 cubed is 10 times 10 times 10, which equals 1,000, and so on. So again, that's really an aside. If you don't know how exponents work, maybe go look up another YouTube video about that if it helps you understand this one, because we're not going to spend a ton of time on it here. But point being, again, we can think of each of these digits as 10 to some power starting at 0. If I were to add another digit over here, that would be 10 cubed, and so on. So I can write out what I had here, where this is 3 times 10 squared, plus 3 times 10, plus 1 times 10 to the first, plus 7 times 10 to the 0. And again, that's going to give me 300 plus 10 plus 7, which equals 317. So again, that is the same thing we had to begin with. Now, binary works the exact same way with 2 key differences. Each digit now represents a power of 2 instead of a power of 10. So this is a base 2 number system instead of a base 10 number system. And each digit can only be 0 or 1. So with the decimal or base 10 number system, each digit can be a value from 0 to 9. I forgot to mention this earlier because, again, it's one of those things we just sort of take for granted at this point after having learned to count and know numbers for so long. So there's actually 10 possible digits because we count the 0 there. Here, each digit can only be 0 or 1. So there are only 2 possible digits, and each digit represents a power of 2. So in this case, I would have 1 times 2 squared, or 1 times 4, plus 1 times 0 times 2 to the first, and that's just 0 times 2, plus 1 times 2 to the 0, which, like 10 to the 0, 2 to the 0 is also 1. So plus 1 times 1. I'm still writing out both lines here for completeness. So that is 1 times 4 is 4, plus 0, plus 1 is 5. So binary 1, 0, 1 is equal to decimal 5. So that was how we convert a binary number to decimal. What if you want to convert a decimal number to binary, assuming you do actually want to do it by hand and not just Google it, which is always an option? We are going to demonstrate that with the number 13. And the process or algorithm for doing this is to continually divide this number by 2 and write down the remainder each time, and then arrange the remainders to give you the binary number. So I think that's a little easier just to see with an example, so I'm going to work it out here. So if I take 13 divided by 2, that is going to be 6 remainder 1. If I take 6 now divided by 2, that is going to be 3 remainder 0. Now I take 3 divided by 2, that is going to be 1 remainder 1, and then I take 1 divided by 2, and that is going to be 0 remainder 1. Okay, so I have my 4 remainders here. Now I am going to arrange them in reverse order. So starting over on the right, I'm going to take my first remainder, and then I'm going to work my way over to the left. And then again, these digits are going to correspond to my powers of 2. So I have 2 to the 0, 2 to the 1, 2 squared, 2 cubed. So if I now go in reverse, I should get 13 again. So I have 1 times 2 cubed, which is 1 times 8, plus 1 times 2 squared, which is 1 times 4, plus 0 times 2 to the first, which is just 0 times 2, and then plus 1 times 2 to the 0, or 1 times 1. So if I add all of those up, 1 times 8 is 8, 1 times 4 is 4, plus 0, plus 1, and I am going to get 8 plus 4 is 12, plus 1 is 13, which is what I started with all the way up here. So the process works in both directions. One quick note, this bit over on the right for 2 to the 0, where we started here, that is called my least significant bit. So the lowest value bit, which is terminology I realized I actually forgot to mention here, each individual 1 or 0 here is called a bit. You may have heard that term in more of a computer science context. And a group of 8 bits is called a byte. Again, that's more computer science terminology as opposed to the pure math. But the least significant bit is over here on the right, and the most significant bit is over here on the left. So when you're doing this conversion process from decimal to binary, the first remainder you get is the least significant bit, or LSB, and the last remainder you get is the most significant bit, or MSB for short. Finally, you might now wonder, well, if I just see this number in the wild written down somewhere, how do I know if that is a decimal 1101 or a binary 1101? And you might get clues, for example, if there's commas in there, then that probably means it's a decimal number. Decimal is also the number system we use almost all the time in everyday life, so it's unlikely that you're just going to see a random binary number somewhere, but again, if you're programming maybe and you're not sure which is which, the convention there in many programming languages is to put a 0B in front of the binary number to indicate that it is a binary value and not a decimal value. So this 0 is not one of the bits. This does not contribute to or have anything to do with the value of the number. This 0B is just sort of the little prefix to say, hey, this is binary 1101, and not the decimal value, and not the decimal value 1101. So again, may depend on what programming language you're using. I'm not a programming guru, so I'm not sure if that varies. But for example, in programming in Arduino, then this is how that is done. So again, check with the specifics of the programming language or math textbook or whatever you have, but that's the convention I'm most familiar with. So, okay, hopefully you now understand how binary numbers work if you did not understand at the beginning of this video. If you're interested in the programming side of this related to the Arduino stuff, I have a bunch more videos about that on my channel, and thank you for watching.